So nice to have you here. My name is Shaheen. I'm a student of drug discovery and safety, which is a study all about developing new medicine on molecular level. And I'm going to take you through some videos of ours. And I'm going to tell you something about science, theories, and evidence.
We will then use the foundations that we have laid to evaluate some of the evidences presented in science in order to find a plausible answer to the question of how life began on this earth.
Throughout my whole education, I had this question coming up about the complexity of our cells. When we look at the cells, it is just so complex that we cannot fathom how all these processes can have come together like this, even if you give it billions of years. And it was always a question to me, is my grandpa really some kind of a monkey? And do we really resemble some blobs of cells? So for that, I went on a journey. But before we go to the journey, of course, we have to lay some good foundations, because every house that has a weird foundation or not a strong foundation, it will not last. I will take you through what is science, what are hypotheses, theories, and what are facts. Alright, so scientific inquiry is basically the way we do science, the way we learn, the way we interact with our world, and the way we receive data and process these data. So it will be a circular way of doing business, as you may call it. So you have your hypotheses, you have your predictions, and you test your predictions, and then you go back to your hypothesis again. And I like it how Explorable puts it about empirical evidence, because empirical evidence is evidence that we can gather either by observation or by experimentation. And these evidences can also allow someone else to look at our hypotheses and say whether the evidence is in favor of or against the theory or the hypothesis that we have presented it. So, in short, our evidence can be used to either support something or to refute something. So now let's look at the hypothesis. An hypothesis is basically not just an educated guess. And I like it how Anna puts it here, and she gives us also an example of an hypothesis, which is basically an assumption that we make to start gathering data. And by these data we can then have evidence that can support it, or evidence that actually is in disagreement with our hypothesis, and this we can then use to either change our hypothesis or completely refute our hypothesis. So in short, an hypothesis is supportable, it is unprovable, and it is refutable. So short, it is sure. As for the theory, the same things apply, because a theory is basically a collection of accepted hypotheses. So also for a theory, the same things hold true. A theory is also supportable, unprovable, and refutable. Sure, in short. So remember that one, we're going to use this term often in our videos. As for facts or laws, these are used to explain some things. They are not there to describe how some things came to be. For example, the law of gravity explains the way objects fall, but it does not describe why they actually fall. And as you see, in short, there is no absolute truth or absolute proof in science. All can be used to support or disagree on a subject. Alright, now let's look at this test case on the evolution theory. And evolution theory was presented by Charles Darwin in his book on the origins of species in 1859. And what this theory actually tells us is that small changes over time in small steps lead to an evolution of species. And so these changes has to be in small steps, and it has to be over long periods of time. It cannot be in very strong leaps. Alright, and I like it how this website puts it, and as we can read in this paragraph here, he explains that genetic variations over time lead to changes which can be passed on to generations. And if a specific generation is not capable to adapt in time, it can actually go extinct. Now let's look at the second paragraph, what he is presenting, and I want you to remember what we were talking about hypotheses, theories, and facts. Here the author is referring to the evolution theory as something that we can almost grasp because of all the evidences that has been presented over the years. However, what he said about hypotheses, theories, and facts was that they were sure, they were supportable, but they were not provable, they were unprovable, and they are refutable. So that is not the way to do science. So did Darwin tell us how we could refute his theory? Actually, he did. He said that if we could find a very complex system that was not reducible anymore, and that the parts of this system could not have originated on slowly evolving systems, then his whole theory would fall apart. Now that is good science. When you present a hypothesis, you also should present a way to disprove your theory. Now, let's sum up what we have learned. We learned that empirical evidence can either be used in favor of or in disagreement to a theory, and hypotheses and theories can be supported, but they cannot be proven, and they can be refuted. So in short, they are sure. And we learned that facts are only there to explain some things, and they are only true under certain circumstances, and that there is no absolute truth in science. Alright, so I want to challenge you with this one. The next video will be about the blob of protoplasm, so be sure to check that one up before you start our next video, so that you will have some ways to think about this thing. And we're also going to look at some early knowledges of the cell and spontaneous generation. With that, I would like to thank you for your attention. If there's any questions that you have, send us an email and we will get to you shortly after that. Thank you very much.